Hey geometry students, Mrs. O'Donnell here. Today we are taking a look at surface area and volume of pyramids. So our goals for today are find the volume and surface areas of pyramids. I am working on getting your schedule together, so you should have all of the videos and the forms for this week. I will continue posting them daily like I have been, and then checking them as the week progresses. Just a quick reminder, office hours tomorrow, our office hours on Monday are canceled. All right, so for our warm-up, I want you to take a minute, go ahead and pause the video and think which shape has a greater area. Now, keep in mind that I know this picture over here makes it look like the square does versus the triangle, but this is not the finished product, right? These are just, ignore these numbers. Okay, pause the video. Make your estimate or make your guess which one has a greater area. And now we're going to check it out. All right, so if you said that the square had a bigger area, you were correct. All right. So next we want to just do a quick review. How do you find, challenge yourself, pause and think about it, write this down to get that really good retrieval practice. How do you find the area, or how do you find the surface area of any prism? All right, so hopefully what you wrote down is that you take the area of each of the individual faces and add them up. Okay, that's how you find the area of any prism. You could also challenge yourself and think, how do you find the volume of any prism? Take a minute, pause the video, write it down to get that really good retrieval practice. All right, so hopefully you remembered that to find the volume of any prism, you take the area of the base times the height of the prism, okay, to find that volume. These are some really good practice problems. If you want to take a minute, you can go ahead and give those a try. But we are going to move on. We're going to talk about cones and pyramids today. We're going to focus really on pyramids. So based on what we know about Cavalieri's principle, what can we say about the volume of these two shapes? So just a quick reminder, actually you may want to take a minute, another good opportunity for retrieval practice. Pause the video, write down what you remember about Cavalieri's principle. All right, so hopefully you're remembering that stack of coins that we looked at with Cavalieri's principle. And we know that the cross sections, if the cross sections have equal area, as you stack them, you'll end up with equal volume. If all of your cross sections have equal area, then your total volume will be equal. So the volume of these two shapes should be equal since all of their cross sections appear to be equal and they have equal height. All right, so pyramids. A pyramid is a polyhedron with a polygonal base and lateral faces. The faces are triangles and they meet at a common vertex. Okay, so we could have a square pyramid, meaning that you have a square base, right? It meets at a vertex and you have four triangular faces. Okay, that would all be congruent in this case. You have a triangular pyramid with a triangle base, and then you have triangle lateral faces that may or may not be congruent depending on what kind of base triangle you have. You have a hexagonal pyramid, right, with a hexagon for a base and of course triangular lateral faces. Okay, and again, it depends. If you have a regular shape, then your lateral faces would all be congruent. If you don't have that regular base, then your lateral faces might not necessarily be congruent. Okay, we want to make sure that we're considering the difference between our slant height and our height of our prism, right? So the slant height here is the height of that lateral face versus the height of the prism is just how tall your prism is, right? And that's an important difference because we're going to need to think about those differences for surface area compared to volume, okay? All right, so how do we find the surface area of a pyramid? So we find the surface area of the given pyramid just like we would find the surface area of a prism. You take all the area of all of the faces and you add it up. One strategy that might be helpful for you is to draw out a net of your pyramid, right? So if we're drawing out a net, I've got, you know, my square 16 by 16 base, and then I've got a triangle on each side, right? If I sort of flatten out my pyramid, right? And you can grab your calculator, right? We know in order to find the area of a square, you just multiply base times height. So 16 times 16, that gives me 256 feet squared or square feet for that base. And then to find the height of, or to find the area of our triangular, one of our triangular faces, right? We're going to do 1/2 times the base times the height, right? And since our base is a square, I have 1, 2, 3, 4 congruent figures. So I'm going to take that and multiply by 4. All right, so it looks like my base of my lateral face, my triangular lateral face is 16, and my lateral height is 10. So I'm going to do 1/2 times 16 times 10, and then I'm going to take that and multiply by 4. So 16 times 1/2 is 8, times 10 is 80, times 4 is 320, right? So let's see here. This would be 80, 80, 80, and 80, right? Or feet squared. Feet squared, feet squared, feet squared, feet squared, right? So I have 256 plus 320, which gives me 256 plus 320 gives me 576 feet squared, or square feet. Okay. All right, so now you might take a minute and try and find the surface area of these given pyramids. And challenge yourself. What's different about these pyramids than the one that we did before? What's the same? Okay, make sure you're really thinking about that. All right, these are trickier. We're not going to go through these examples exactly. These are a little trickier because we don't necessarily have a formula for a hexagonal pyramid for that base, the area of a base that's a hexagon. So my recommendation to you is always, whenever you can, break something that you're not sure how to do into smaller chunks that are more manageable. So what you could do here is you could chunk this hexagon into 6 separate triangles and find the area of each of those individual triangles. And then thankfully it looks like it is a regular hexagon, so each of the lateral faces should be congruent. Same thing over here with this pentagon, right? If you don't know how to find the area of a pentagon, chunk it into 5 equal triangles. And then same thing here, it looks like we have a regular pentagon, so all of our lateral faces should be congruent. All right, so now I want to talk to you about the volume of a pyramid. We can derive the volume formula of a pyramid from the volume formula for a rectangular prism, just like we derive the formula for area of a triangle using what we know about the area of a rectangle, right? We take the area of a rectangle, we split it in half, we get the area of the triangle with the same base and height, right? So let's check out this video and see how we can derive our formula for the volume of a pyramid based off of volume for a rectangular prism. so hopefully you saw how many triangular or how many pyramids were poured into the rectangular prism or the cube that's the same height as the pyramid. 3, right? Awesome. Okay, so that's how we get to that formula for volume of a pyramid. We take our area of our base times our height, just like we would for any prism, right? You take the area of the base times the height of the prism, but now we're actually going to divide that by 3, right? Because just like we had those 3 pyramids poured into that one prism, right? If you want to just figure out how much the volume of one pyramid is, you cut it into thirds. All right, so let's try out this formula. All right, so if we're trying to find the volume of this first prism, the 16 by 16, we're going to do volume equals, and we're going to do our area of our base, which is 16 times 16, or 16 squared, times the height of the prism, which is 6, and then we're going to take that and divide it by 3, right? So you could grab your calculator to help you. 16 squared times 6 divided by 3, and that's going to give us 512 feet cubed, or cubic feet. Okay, and then we could do the same thing over here, right? If we want to test it out, okay, to find the volume of this other pyramid. So same deal here. You're going to do volume equals 6 times 6 times your height of your pyramid, which is 4 meters, and then divide that by 3. So 6 times 6 times 4 gives us 144, and then divide that by 3 is going to give us 48 cubic meters, because volume is always 3-dimensional. It's always cubic. And that's all I've got for you guys today. So go ahead, make sure you log in to Delta Math, work through any Delta Math relating to surface area and volume of pyramids, hop on to the daily Google form, complete that to get your attendance and your participation credit for the day. Remember, don't forget to come to my office hours if you have any questions or need any help, and bug your friends to make sure that they're doing their work. All right, thanks so much, guys, and I will talk to you later.